To write formulas of single valent ionic compounds, it's important to remember what's an ionic compound. This is when we have a metal and a non-metal combining together. An example might be something like sodium oxide. To write the formulas for this, we have to look up each of the symbols and the charges for each of those two names. So sodium has a +1 charge and the symbols Na. Oxide, which is oxygen, has a symbol O and a 2- charge. Now, when each of these elements combine together, they have to do so in a specific ratio. The ratio has to do with the charges. The charges have to be in balance in order for these to combine properly. So what I mean is because we have a -2 charge on this side and a +1 charge on this side, I need to add another sodium in order to balance out. So now I have +2 on this side and -2 on this side. And so what that tells me is I have in this compound 2 sodiums, and we use a subscript to indicate that, and 1 oxygen. Now we don't write the 1. Whenever there's no number there, it's assumed that that 1 is there. We just don't write it. There is another option to solving these questions, and it's called the swap and drop method. And in the swap and drop method, you still have to find the symbols and the charges, except this time you swap and drop the charges. And so that 2 goes with the Na, and the 1 goes with the oxygen. And again, we don't write 1s. Now, the swap and drop doesn't work every time, and I'll show you an example of when that happens. For example, if we have magnesium oxide, magnesium, we use our periodic table, we find out its symbols are Mg with a 2+ charge. Oxide is O with a 2- charge. If we go to balance these charges, 2+ balances out with 2- already, and these combine in a 1-to-1 ratio. Mg, we don't write the 1, O, we don't write the 1. If you're to do swap and drop, you need to remember that we have to balance these in lowest terms. So if you think the 2 might go down and the 2 might go down, we cannot write Mg2O2. This is incorrect. We have to go to lowest terms possible, which would be MgO.